That's what that 6% is for. It's supposed to be is kind of a generalized idea of what inflation is. I've also heard that 4% is a good number to use. We're using 6 to be on the safe side. Another question. Yes, I do. They were right there. So moving forward here. So basically, let's grab the simple points first. Your name, your hour, your teacher. I'm gonna do the freshman one just because that is the largest. The only difference between the freshman, sophomore, and junior ones is just basically how long before you start school. So the freshman ones will have extra years here before you start school. Besides that, the worksheets are the exact same. So hour, this is 5th, and teacher is me again. All right. So so the school that I chose and I was going back and forth here. Yes, I chose the University of North Carolina, Greensboro. So UNCG or Greensboro. And the reason why I chose that school is because that's where my sister went to school. So or I should say that's where she did her graduate studies there. So so jumping on their website, I just added up for what their annual tuition, room and board was for out of state, and they said as the grand total there that it was going to be $29,758 for 1 year, and that's for the 15-16 year. Yes, sir.
So you wouldn't just make like so when you look up it says tuition.
Mm-hmm.
So you have to add the room and board to that.
I would. One, cause it asks you for that. Some of the colleges, yeah, the goal of this project is not to underestimate so that it looks okay. It's always safer to overestimate because it's easier to be like, oh, I guessed that this was going to be $1,000 and it only cost me $800. Well, then I'm plus $200 there versus underestimating. Then all of a sudden you don't have enough money. So so that's kind of what Mr. Server was hinting at there, was just saying it's better to put more expenses in than it is to put less expenses in, because that's going to give you a more top-heavy number there. Does that make sense to everybody? Awesome. Yes, another question.
So with my specific project, it has like an orientation fee for 1 year.
Okay.
Do you want me to add that to like the total because it's not like a recurring charge?
I wouldn't add that to the total since it's a 1 year thing. Is it super expensive, or is it like? Is it like $2,000, or is it like?
I don't have it up right now.
Okay. Oh wow, that's actually a fairly decent amount. Yeah. I wouldn't add that in because since you're not going to be paying that each year, it might just be something that you can throw in at the very end of your equation to say, hey, here's my total cost, and then just add one line of plus $4,000 for this freshman orientation. That would be a good extra piece to like throw in there, because once again, we're trying to get as realistic of a cost as possible. So where you can find these things on basically every college website, if you just search for it, it'll be the admissions tab, and then cost is usually one of the pieces underneath there. Lots of schools will break it down into each of the individual costs from annual tuition, room, and then board. They'll sometimes split that out, or sometimes they'll have it all be one piece. But yeah, so in this case, my annual tuition, room, and board is $29,758 for UNCG, so University of North Carolina, Greensboro. So since I'm doing a freshman one, I'm going to account for this inflation here, which is going to be 6% annually. So if we're going to use what we know so far about the recursive equations, we can set up a recursive equation for this guy. Just say that at our starting value was that 29, so u of 0, or in this case, this is even going back to our previous unit. This is where it would be good to, since this is an annual rate, this is where it'd be good to do what we were doing before and set up our starting value as one of these years, so that it's easier to find it. So I always start with the starting year. So U of 2015, because that's this current year, it was 29,758 for the cost for UNCG. And then from there, we're just doing a basic geometric sequence here. So you can set this as 2016. I'm just setting it as 2015 because that's the first number that's showing up here. But you could set it as 2016, but you just have to reference the second number in that. Either way works. But this is just how I'm doing it. I'm basically just basically running through a sample so that you guys can kind of see how all this stuff goes. So 6%. So that is U of n is equal to U of n minus 1 multiplied by 1 plus, and then it's growing 6% annually. So what do I put in this next blank here? See if I can get some help here. Yes. 0.06. And do I have to do any compounding monthly or anything like that? Nope. Just an annual interest rate. And then it's just growing. There's no shifting with this. There's no anything that we're paying down on that cost there. So it's just growing by 6%. So this is where we can punch this into our calculator and then see what that is going to grow to. So if we're going to do that here with ours, and this is just the example I'm doing. If you want to follow these exact same steps and just use the cost or tuition that you've come up with, that's great. Just to keep following ahead there. So in fact, why don't I do this? We're just going to write in this recursive equation into our calculator. So nothing crazy. This is what we've been doing for a while now. Multiplied by 1 plus 0.06. And my starting value is 29,758. Your starting value will be whatever your 2015 16 amount is there. And that's all that we're looking for. Then of course, I did forget a step. What step did I forget to do here? Yes, sir. Do the domain or the minimum, since I set mine to be 2015 so that I could easily find the year. Just be sure and set that to 2015 or 16 if you'd prefer to do that. It won't blow out the calculator like our other ones have because this is saying what's my minimum. So basically, once I hit 2014, it'll just give me an error.
Oh, yeah, okay.
Yep. And then one, be sure and change your table set to reflect that so that we can actually be looking at those values. And then take a look at your table set from there. So with that interest now, we're going to be looking at something like this. So I'm looking for my 2019, 2020, 2021, and 2022 yearly costs. This is all doing it for freshmen. If you're going to be or if you're a sophomore or a junior, these years are changed on here, so you'll be looking down less rows on your calculator. Yes. Then that probably means that you punched in your equation into the y equals wrong. Whenever you get some sort of an error like that, it's saying that right. So that means that you probably don't have the right table set. So go to second and then window, and have your table start at the year 2015. Yep. All right. So jumping back over here. So the only difference between freshman, sophomore, and junior is just what year you're starting. If you're a junior, you should be starting it in 2017. So you just go down to the third one. I believe that math is right. If you're a sophomore, you should be starting in 2018. If you're a freshman, you'll be starting in 2019. So in my case here, the number that I'm pulling up here, my estimated cost of tuition here will be 37,568, and then we'll keep our normal rounding and round to the penny. So 37,568.79. So that'd be my first year's cost. And then I just keep going down this chart. So my second year.
Wait, so we're all going to have the same inflation? It's just
This is just what this is doing is this is just estimating for inflation. So basically, your price increasing over the next few years, because most schools don't keep their price the exact same from year to year to year. So this is just an estimate for what do we think that price increase will be over the next 2 years if you're a junior, 3 years if you're a sophomore, or 4 years if you're a freshman. That's all that this is going. You shouldn't have these same numbers here because your starting value is different. But the equation should be the same. Yep, because all of us are doing a flat 6% growth as an estimation there. So then you'll just go through and you'll put in each of these numbers here, and then you'll just add them all up. So when I went through and added all mine up here, yes, it should be a lot of money. So mine was 164,349.03. All right. So coming back in here. So come back in. So once you have your total, the reason why we're taking it in half is because we're guessing that maybe you'll get a scholarship. Maybe for example, my sister with this school, they actually made it so that she could have in-state tuition instead of having out-of-state tuition, which would completely change my numbers here, because I believe that in-state was about 7,000 a year versus 29, it maybe with room and board. But I mean, that's a piece that she got for going grad school and for grades. She's crazy smart. So yes.
So after we get all those totals, add them up and divide half.
And then divide in half. And the reason why we're going in half is we're saying, maybe mom and dad are helping out, maybe grandma and grandpa are helping out, maybe there's a scholarship, maybe you have a cheaper option for room and board, different pieces like that might drop your total. And there's lots of scholarships out there. There's lots of different pieces like that. They could make it so that you're not paying the full amount here. Lots of people really like to help people get through college. So then from there, you're just taking half of that total. So mine here, I ended up with 174.51, and that is, of course, rounded. So we're going to keep going ahead here because I want to be sure and get through the rest of this, and we've only got a couple minutes left here. So once you've got half of your total here, we're now going to figure out. So this is the amount of money that we're estimating you're going to have to pay back off from student loans once you get into your working adult life. So then the next step here will be the recursive formula to figure out how we're going to do that. How are we going to pay off this amount of money? So let's slide right down here. So my number, once again, was 174.51. So this is my total divided in half. So this is the amount of loans that I think I'm going to have to pay. So next, you're going to set up a recursive equation to pay off the loan in 10 years, 7% interest compounded monthly. Real quick about this number. This is a little bit high from what my wife and I have with our loans, but she had a couple of decent ones in private loans. You'll generally see rates that it could even be higher than 7%. I have a few friends who have 10% interest on their loans. So this is kind of a good number to go off of. It might be a touch high, but it's a pretty good number. So set up a recursive equation to pay off the loan in 10 years. So let's first set up the recursive here. So U of n is equal to U of n minus 1 multiplied by 1 plus 0.07, and we're compounding this annual interest rate monthly. And then what we're looking for is we're going to be making payments. So we're trying to figure out what is that payment number going to be. You know, I'm rounding to the nearest penny, but I mean, if you round it to the nearest dollar, that would be fine. So, but I'm doing penny, just to get a little bit more exacting. So calculate the amount needed to pay each month in order to pay off the loan in exactly 10 years. Since it's compounded monthly, that'd be 120 months. So this is where we can use that finance app. That it's a little bit hairy. It tends to work well with these. It's more the investments that we're kind of running into some issues there. So with our finance app that we've been using, you can just go over and jump into the finance app. So it's finance, then TVM solver, and we know. And let's put in the things that we know about this. So it's going to be paid off over 120 months. So my N is going to be 120. So that's the number of payments that I'm making. My interest rate is going to be at 7%. 7%, which is right up there. So I can just do 7 because it's already in the percent form. The present value, this is where we want to have that be the your number up here. So 82, in my case, be 82. Can't read right. Okay, 174.51 would be my amount there, and I'm missing a number. 82, 174.51. All right, and then the payment is the piece that I'm trying to figure out. I don't know that amount, but the future value, eventually I'd like to pay this loan off. So we're going to move that to a 0. Our compounds, we're going to be compounding it every month, so that'd be 12 compounds. And then this is where we can use that alpha solve to figure out what this number should be. Yes. Or, yeah. Questions, go.
Okay, so what I did is I think this is the test.
Yeah.
Well, when I put it in the thing, I did the starting value, I did that as negative, and then the payment value is positive.
Yeah, you also can do that too. In my case, it comes out being a negative number, which of course then you convert it to positive. But if you insert a negative number here, you'll find that it gets to a positive number there. So yeah. So yeah, I mean it's a little bit simpler to insert the negative on the present value, but either way works. Yes. How they used to do it and why we started using it is it's literally a little bit of a guess and check approach. So just saying, hey, so basically going into your y equals and saying, okay, I think I'm going to need about $1,000, and then you figure out what u of 120 is, and if it's negative by a lot, then you're probably off. So then you have to guess the new number, and that's why this finance app was being used. It just takes that guessing game out of it. So does that make sense, Jake? Yes. Question, Tor.
So you just that number to subtract from your value anyway, so.
Yeah, this is then, so this payment amount is what we're putting in right there into the equation.
Is it okay if we just use that
That is okay.
second line? Like, I don't get how you're clicking on the payment and getting an answer.
So then that's where we're doing that alpha, and then down here is the solve, or which is on the enter key. So if you do alpha and then enter, it should solve that equation for you. Yes?
Would it be normal for your actual pay, like how much you actually pay, to be like a lot more than what your fund was? Mine's like 29,000 more.
So
I don't know if I did it wrong.
can you say that again? I'm not sure I tracked with you.
I paid like $99,000
Okay.
for like a $70,000 loan.
Yes. Yes. Why do you think that would be different? Yes, because the interest. Because the bank wants to make money. I mean, like the bank is giving you $70,000, right?
Big number like that.
Well, you know, it's not. Is the short answer. It depends on what your interest rate is, depending on how long you're paying it off. You know, all those things can change it. I have to remember what my number is here, but let's forge ahead here because I for sure want to get to the last section of this here. So in my case here, I'm paying $954.12 per month. So $954.12 per month. The next step here would be, oh man, struggle. All right, would be yes. Calculate how much you actually paid for the loan, including interest over 10 years. That's a matter of saying, okay, I'm paying $954.12 per month over 120 months, and then from there, figuring out what that number is. And this is what we're doing yesterday, and then going to our y equals table and seeing how much you missed it by. In my case, I believe I only overpaid by 11 cents because it should be pretty close because we're trying to find the exact value of basically what that should be. So it should be really close. But 120 months times by that should be what you're looking for there. So my number ended up being 114. Let's see here. 114,493.66. So in my case there, the original amount was 82. My final amount was about 114. So very much in the same ballpark there. This is saying the total amount that you actually paid for your loan. So this is how much the bank loaned you. This is how much you actually paid for that loan. Yep. Yeah, it's a big number, but it's also a big number that the bank is loaning you. They're loaning you $82,000. I mean, that's lots of money. All right, the last piece is income here, and we're going to fly through this here because we just got a couple of minutes left. So now calculate the monthly income that you would need so your loan payment is no more than 8% of your income. So you don't know what your income is. So we're going to call that X, but we know that we need, in my case, it's $954.12, and in my income, so this number has to be equal to 8% of my income. So if I'm saying that X is my income, this is 8% of my income should be equal to $954.12, which is what my monthly payment is. And of course, we're just dividing and solving. So in my case, X ends up being, I need about a monthly income about $11,926.56. That's how much money I'd need each month in my paycheck to not go over 8% there. And Jake, I see your question, but I'm going to make sure and hit this last one here because we're just about out of time. So last piece here that we want to look at, based on the monthly income, what would the annual income be? Well, since we have our monthly, mine was 11,009 something. We're just multiplying that by 12. So just multiplying that by 12 to get what my yearly income is. And the fun fact, this would be all before taxes. So then you have to figure out how much your tax rate would be, which is not part of the worksheet, but that's an interesting piece there. Thanks, guys.